Wow, this is incredible, Mr. Ikret. The lab looks amazing. I'm pumped to be here.
Welcome, buddy. I'm Mr. Ikret, the master of precision from iCrategy. And today is your lucky day. We are diving into the world of HPLC.
Woo, this is going to be awesome. I'm Mr. Doubt Buddy, ready to learn everything. You've got to show me how the magic happens in here.
Get ready, Mr. Doubt Buddy. The Quality Control Lab, where we turn science into success. Let's unlock the secrets of HPLC.
Let's make precision happen.
Hello, Mr. Doubt Buddy. It seems you're eager to learn about the HPLC machine today. Are you familiar with what HPLC stands for and how to operate it?
Hello, Mr. Ikret. Did you say LG? Are you talking about the TV brand LG?
Haha, not quite. HPLC stands for High Performance Liquid Chromatography, an advanced technique used to separate, identify, and measure components in a mixture.
Oh, fascinating. So, what's the difference between liquid chromatography and HPLC?
Great question. Liquid chromatography separates, identifies, and quantifies components in a mixture using a stationary and mobile phase. HPLC is an advanced version, offering more precision and speed, crucial for pharmaceutical analysis.
So, HPLC is a key instrument in quality control?
Exactly. In pharmaceuticals, accuracy is everything, and HPLC ensures to meet those high standards. Alright, Mr. Doubt Buddy. Now that you know what HPLC stands for, let's go over the major parts of the HPLC system.
Sure, Mr. Ikret. How many parts are there? And are they really that important?
Great question. Yes, each part is crucial. There are 6 major components: solvent reservoirs, pump, injector, column, detector, and data system. Let's start with the solvent reservoirs.
Solvent reservoirs. Sounds like fancy bottles. Are they that important?
Haha. They may sound simple, but they are very important. They hold the mobile phase, the liquid that moves your sample through the system. We can use an isochromatic mode for constant solvent composition or a gradient mode for more complex mixtures.
Isochromatic? Gradient? Those sound complex. Why would you choose one over the other?
Isochromatic is faster for similar components, while gradient is better for complex mixtures by adjusting solvent composition. The degasser and mixer ensure consistent solvent flow for accurate analysis.
So, what's the deal with the pump? Isn't it just there to push the liquid through?
Exactly. The pump drives the mobile phase through the system at a controlled flow rate and pressure, like the heart of the HPLC, ensuring smooth and steady operation. A reliable pump is a key for accurate results.
Alright, but what about the injector? Sounds like a simple needle job.
Not quite. The injector introduces the sample into the mobile phase stream precisely and at the right time, either through an autosampler or manually. A small mistake here could affect the entire analysis.
Got it. What about the column? It's just a tube, right?
Not just any tube. The column is the heart of the HPLC, where separation happens. The guard column protects, and the analytical column handles separation. Column choice depends on the sample and requires separation.
Ah, so are all columns the same?
No, they vary in size and material depending on the application. For instance, normal phase and reserved phase chromatography use different columns.
Oh yes, it makes sense. And the detector? Is that like a camera that catches what's coming out?
In a way, yes. The detector identifies and measures the separated components. Different detectors are used for different analytes, but they all collect data for analysis.
Oh, I see. So the detector finds the components. But is there different detectors for different samples?
That's where the data system comes in. It collects the signals from the detector and creates a chromatogram, visualizing the separation process.
That's pretty cool. But how do you make sense of all the data the detector picks up?
That's where the data system comes in. It collects the signals from the detector and creates a chromatogram, visualizing the separation process.
So the detector just sends signals and the data system turns them into a graph?
Exactly. The peaks on the chromatogram tell us both the identity and quantity of the analytes.
That's amazing. How do the peaks show us the concentration?
The area under each peak indicates concentration. The software calculates it, giving us precise quantitative data.
So, the data system doesn't just display the graph, does it analyze too?
Yes, exactly. It processes raw data into meaningful information, integrating both qualitative and quantitative results.
Got it, Mr. Eichwett. Each part really does play a crucial role. Thanks for breaking it down for me.
Anytime, Mr. Doubtbuddy. Understanding these parts is key to mastering HPLC. Keep asking questions, and soon you'll be an expert too.
Mr. Eichwett, I've been thinking about the parts of the HPLC system. How do they work together?
Great question, buddy. Let's break it down step by step. At the end, you'll see how every part contributes to smooth operation.
Wow, it's so interesting. Please let me walk through.
The first thing we do is prepare the system. Think of it like warming up before a workout. Here's the main power switch at left side. Always start by turning it on. Next, you need to prepare the mobile phase. This involves mixing the solvents according to your method and then degassing them to remove air bubbles.
Air bubbles? Why are they such a big deal in the system?
Great question, buddy. Air bubbles can cause fluctuations in the pressure and disrupt the flow of the mobile phase, leading to inconsistent results. Finally, make sure the correct column is installed and all connections are tight.
How do I know if the connections are tight enough? Is there a specific way to check?
Look for a firm fit and no gaps to avoid leaks.
Thanks for the tip. It's reassuring to know what to look out for.
Now, let's talk about priming the pump. This is an essential step. Open the purge valve and let the mobile phase flow until there are no air bubbles.
How do I know when the lines are completely free of air? Can I see the air bubbles?
Look for a steady liquid stream and check the pressure gauge. It should stay normal. With the system primed, the next step is to set up the method in the HPLC software. Input method parameters like flow rate, column temperature, injection volume, and detector settings to match your analysis requirements.
There are so many parameters to set, it seems. How do I ensure I'm inputting the right values?
It depends on your method and analysis. The method provides the parameters which you can double-check against standard testing procedures (SOPs) for the proposed product. After setting the method, run the mobile phase at the set flow rate until the baseline stabilizes.
How long does it usually take for the baseline to stabilize?
It usually takes 20 to 30 minutes depending on the column and mobile phase. Just ensure the baseline stays stable with no drift.
So patience is key here. I'll wait until everything is stable before moving on.
Now comes the crucial step, injecting the sample. Whether you're using the auto sampler or a manual injector, ensure that the sample is introduced into the system correctly.
How do I verify the volume?
With manual injections, measure what you draw from the vial to match the set volume. With the sample injected, the components separate in the column and the detector generates a chromatogram.
How do I read the peaks?
Retention time identifies the compound and peak area shows concentration. After the run, flush the system to prevent contamination. Then power down in reverse order, starting with the detector. Regular maintenance like checking seals and filters ensures the system stays reliable.
How often should I maintain it?
Daily for simple tasks, but some can be weekly or monthly.
Thanks, Mr. Aikret. I feel ready now.
You're on your way, buddy. With practice, you'll master with this system.